course, we're missing 2 and 4, but we're going to work those out. We're told the probability the spinner will land on 2 and 4 is equal. And then we have Ravina is going to spin the spinner a number of times. He works out an estimate for the number of times that the spinner will land on 3 is 45. And we're asked to work out an estimate for the number of times the spinner will land on 4. So whenever you're approaching problems like this, which seem sort of quite confusing at the get-go, it's always good to think about what you're trying to work out and what you need to do that, okay? So if we're trying to work out an estimate for the number of times something will happen given the probability, well, we know that we can take, the number of trials, multiply this by the probability of that event, and this will give us the expected number of outcomes, okay? So, if I'm going to flip a coin and it was a fair coin 100 times, right, and, for heads and tails it's 50-50, right, I'd expect 50 heads, right, because 100 times 0.5 is 50. So the idea is that, well, if I want to know this, I firstly need to know, what is the probability of getting a 4, and I also need to know the number of trials, right? The number of times I'm spinning the spinner. But I don't know either of those pieces of information, so I need to try and work both of those out. Well, the first piece is to work out the probability of landing on 4, right? And we can use the fact that, we've obviously been told this for a reason, so these two probabilities are equal, so let's just call them x, right? And the idea is that, the sum of all the different outcomes, right, the probabilities of those different outcomes must give 1, right? Because it's certain that I will land on 1, 2, 3, or 4, okay? So what that means is that 1 must be equal to 0.26 plus, x plus x, so it's going to be 2x, plus 0.18, okay, so this is 0.44. We can subtract the 0.44, if you like, the 0.26 and the 0.18 from both sides. That gives me 0.56 is equal to 2x, and then I can divide this by 2. This gives me x is equal to 0.28, okay? So that's my probability of getting a 4 on this bias spinner. And then the idea is that I need to think about, okay, well, what is this information telling me, right? We know that we need the number of trials, and that is precisely hidden within this calculation that Ravina has done. Because how would you work this out? Well, you would take the probability of landing on a 3, multiply it by the number of trials, and that would give you 45, okay, using this sort of, formula down here. So what that tells me is that, the probability of getting a 3, which is 0.18, okay, so 0.18 times the number of trials, which we'll just call n, must be equal to 45, right? Which is the relative frequency, or the expected frequency, expected number of outcomes, whatever you want to call it. So I just divide both sides here by 0.18, okay? So 45 divided by 0.18, that gives me 250, okay? Which tells me that, the number of times he spun this spinner was 250. So what is the expected number of times we would get a 4? Well, that's just going to be the number of trials, 250, multiplied by the probability, which we worked out to be 0.28, okay? So we can take our answer here, 250, multiply this by 0.28, and that will give me 70 as our expected frequency for the number of times the spinner will land on 4.